In this lesson of 7.2, we're going to be looking at parallelograms, and we're going to be talking about the different properties they have specifically, like their angle properties, and then their side lengths. So parallelograms are always a quadrilateral, okay? They're a quadrilateral that has two pairs of opposite sides that are going to be parallel, okay? It's not just one set of sides, it's both pairs have to be parallel to each other. And so whenever that happens, we have some different properties that are going to exist. First of all, our parallel sides are always going to be congruent. Okay, the sides that are parallel, not all four sides, but the sides that are parallel are going to be congruent. And then also our opposite angles in our parallelogram are going to be congruent as well. So when we go across from each other, you can see those two are the same, and across, those two are the same as well. So in this first example, we're going to use those properties. So we know opposite angles are going to be congruent, and we know that our sides, basically our opposite sides as well, our parallel sides, are congruent. So when things are congruent, remember we can set them equal. So if I do my opposite angles first, I can do y is equal to the opposite angle of 65. So there's no solving in that one, we just already have y is 65. Our opposite sides, we have x plus 4 would be equal to 12. To get x by itself, I subtract 4. So I get x is equal to 8. Okay, that's all you have to do. Opposite sides and opposite angles. They're always going to be congruent if it is a parallelogram. So we can kind of think back to when we had parallel lines and we had transversals. So in this picture that we have up here, we have a set of parallel lines right here. Okay, we have our arrows that show us they're parallel. And then we have our transversal. Okay, our transversal, remember when it cuts across parallel lines, it makes different sets of angles. And one of those sets of angles is going to be the consecutive angles that are inside. Okay, our consecutive interior angles always are going to be supplementary. Okay, remember we had that theorem, and so it told us that these would equal 180 degrees when we add them together. So in a parallelogram, we're going to have the same thing happen. Because we have those parallel lines, the other side works as though it's like a transversal. So since in this diagram, QR is parallel with PS, QP here would be my transversal. And so that means that we're going to have those consecutive interior angles are going to be equal to 180 degrees when we add them up. They're going to be supplementary. And so then the last theorem that we have to think about in parallelograms is our parallel diagonals theorem. Okay, remember diagonals connect opposite vertices. Okay, they cannot be consecutive vertices. Consecutive vertices are already connected by a side. It has to be opposite vertices. And then whenever we do that in a parallelogram, those diagonals connecting those opposite vertices are going to bisect each other. Okay, so that means when QS bisects PR, we're going to have these two different sides. So we have each side, if you notice, it has the little tick marks on each side of this one to show that each half of it is exactly the same. And same goes going the other way. We have each half of these is going the same. Notice, though, they are not the same length, though. Okay, QS is not the same length as QR. QS is going to be shorter than QR because those vertices are closer inside together. And then PR is going to be longer, but they cut each other in half. In this example 2, we have that an extended arm of a desk lamp is a parallelogram. It tells us that it's going to change as the lamp raises and lowers. And it wants us to find BCD. So BCD is this angle here. When ADC is 110. So we have ADC right here, and this one is a 110. Okay, so we have two angles. They're not opposite of each other, right? If they were opposite, like the opposite angle here, this one would be 110 up there. But instead they are right next to each other. They are consecutive angles. Okay, these two are going to be consecutive. And so if they're consecutive, that means that they are sum up to be 180. They're supplementary. Okay, so if I add them up to be 180 degrees, so right now I'm going to say that this one, measure BCD, you can either say measure BCD or you can put a letter there if you'd rather put an X. Okay, but I'm going to put that I have 110 degrees plus the measure of my BDC, or BCD, I'm sorry, BCD would equal 180, right? We said they're supplementary, they add to 180. So then all I have to do is solve, so I would subtract 110 from each side. So I get the measure of BCD is equal to 70. And so that would be my answer. If they had asked me for BAD also would have been 70 degrees. And again, like we said earlier, the opposite angle of ADC, of ABC, would have been 110. So in this problem, we're going to find all these indicated values here that are on the left using our diagram, and using all these properties that we just learned about parallelograms. Okay, so first it asks us for LM. Okay, so LM is going to be, it's a side, so our sides are always equal to the opposite side. So if I look opposite of LM, okay, it's 13, so that means LM would be 13. If I keep going, we have LP, but let's look at our other opposite side first. We have this 8 here, so it's going to be on the opposite as well. So LQ would also be 8, so I'm going to go ahead and write it over here. Then it asks us for LP. I'm going to go ahead and erase some of this. Okay, LP is part of our diagonal. P is the intersection of both diagonals. Okay, and remember that we said our diagonals bisect each other. So if we have P in the middle, it's going to be the midpoint of both those lines. So LP is going to be the same length as PN, and we have QP is going to be the same length as PM. So LP is the same length, like we just said, as PN, so since PN is 7, that means LP would be 7 as well. It then asks us for MQ. We have in this diagram that PM has a length of 8.2, you can see here. So the other side would also be 8.2, but they ask us for MQ. It's the whole thing, so all I would do is add them up. So I'd have 8.2 plus 8.2, so that would give me 16.4. Again, I'm going to clean some of this up so we don't have so much going on. Now we get to angle measures. Okay, remember opposite angles are always equal to each other. And then consecutive angles are going to be supplementary. So we only need one angle in a parallelogram, and we can solve for all the rest. Okay, so first we have this angle of QLM. So QLM, it tells us, is 100 degrees. So that means opposite of it is also going to be 100. So let's try to find this one. We have MNQ, which is down here. So I'm going to write it in that it's 100. So then if we look, they ask us for LMN, so that's this angle that's up here. Okay, so we can use our consecutive angles. Okay, consecutive angles are always sum up to be 180. They're supplementary. Okay, so if they sum up to be 180, I would have 100 plus measure of LMM would equal 180. So if I subtract 100, measure of LMN is equal to 80. Then I need NQL. NQL is the opposite of that angle, so it's going to be congruent with it as well. So we have 80 for it as well. And then in this last one, they ask us for LMQ. I'm going to go ahead and erase everything because we don't really need anything else in this diagram for that. So when we look at LMQ, LMQ is the angle just on this side, up here. Now, we don't have any theorems in this current chapter that told me how to find that. But if you notice, on this other side down here, we have 29 degrees as MQN. So if you think about our parallel lines, if we extended LM going on, they're parallel to each other, and we extended QN, and we looked at MQ as a transversal, notice that these two angles here would be opposite interior angles. Okay, they're on opposite sides of our transversal, but they're still in the interior. Okay, that's what we call alternate interior angles. And alternate interior angles are always congruent. Okay, it's something that we have to be able to recognize when we see it. They're always going to be congruent. So, since MQN is 29 degrees, that means LMQ is going to be 29 as well.